Everyone, welcome back to AI Academy's course on Python for data science. In our last lecture, we have worked on the classification case study where we classified individuals based on their income. Today, we will be looking into regression or function approximation case study. This is our second Capstone project, and it's all about predicting the price of pre-owned cars. So, what's different this time? Well, in the previous case study, we were simply categorizing individuals into two groups, those earning less than $50,000 and those earning more. It was a binary classification problem. But now in this case study, instead of classifying, we will be predicting an actual numerical value for the price of a used car, which a use of regression model. So, if we talk about the problem statement, imagine a company called ABC Motors owns an e-commerce platform that acts as a middleman between people looking to buy and sell pre-owned cars. They have tons of data from past sales, collected both through their platform and other sources. Their goal is simple: to make sales happen quickly. To achieve this, they need to ensure that the prices are right, satisfying both the seller and the buyer. If the price is appropriate, cars will sell faster. So, ABC Motors wants to develop an algorithm to predict the price of cars based on various attributes of the car. Think about how useful this can be from ABC Motors' perspective. If a seller lists a car for a certain price, ABC Motors can input the car's attributes into the model and get a predicted price. If the seller's asking price is way higher than the predicted price, they can advise the seller to lower the price to make a quick sale. This is a classic example of a regression problem. We're not just classifying into categories, but we're predicting a continuous value. And that's what makes this case study so interesting. Now, let's consider the buyers. If a buyer comes in and bids a much lower price than what's listed, you can show them the model's results and say, "Hey, you're asking for a very low price." The seller is unlikely to accept this offer. By doing this, you can optimize the transaction, making both the buyer and seller happy, which in turn boosts your business. Just like we did with the classification problem, we'll think about this data in a matrix format. ABC Motors has data on around 50,000 cars that have been sold or processed in various ways. There are 19 variables associated with this problem. One of these variables is our target, which is the price of the car. The other variables contain information that will help us predict the car's price. Let's break down some of these variables. One variable is called date crawled, which is of date type. This variable indicates when the ad for the car was first crawled or viewed. Essentially, it tells us when people first started looking at this car. Another variable is name, and it's a bit more complex. This variable, which is a string, can include the car name, brand, model, and more. It's a composite string, and you'll notice in this dataset that the information isn't always consistent in order. The seller type variable indicates whether the seller is a private individual or a commercial entity. Then there's the offer type, which tells us if the buyer made an offer after seeing a specific car or if the price is what the seller asked for initially. The price variable is our outcome variable. It's the listed price to sell the car. This is what we're trying to predict. The way these ads are set up, they come with certain characteristics. Storm Motors also conduct specific studies, so ads could be classified as either test or control, and this is noted as a string. Vehicle type is another string variable, indicating if the car is a cabrio, SUV, coupe, or one of 5 other types. The year of registration is an integer that tells us when the car was first registered. Clearly, many of these factors will impact the car's selling price. For instance, the vehicle type is obviously significant. We'll explore more variables as we go along. For example, whether the seller is private or commercial could matter. Private sellers might hold out for the best price, while commercial sellers might want to move inventory quickly. We can't be sure of the impact until we analyze the data, but these are all relevant factors. When tackling a data science problem, we assess the relevance of each variable to the problem and then determine their quantitative impact through data analysis. Another variable is the gearbox, which can be manual or automatic. We also have power, an integer representing the car's power, and this can have multiple values. The next variable is model, which refers to the specific model type of the car. For example, if it's a BMW, is it an i10, i20, etc.? The month of registration variable tells us the month in which the car was first registered. The fuel type variable indicates whether the car runs on petrol, diesel, or one of 5 other fuel types. The brand tells us about brand of the car, like is it a BMW, Mercedes, or something else? We also have a variable that could be crucial in determining the car's price, like not repaired damage, or variable indicates if the car has any unrepaired damage. If the value is yes, it means there has been damage that hasn't been repaired. If it's no, the damage has been repaired and rectified. You can see how this might significantly affect the car's price. And the other variables include date created, the date when the ad was created on ABC Motors. The postal code of the seller, which can provide location-specific information. The last seen variable indicates when the ad was last seen online by a crawler, giving us an idea of the most recent activity and interest in the car. These are all the variables we'll be working with to predict the price of pre-owned cars. In the next part, we'll start exploring the data and setting up our regression model to make these predictions. Alright, so let's break down the variables and understand their potential impact on predicting the price of pre-owned cars. Think about it this way, each variable we have could potentially influence the car's price. For instance, if a car isn't getting much attention, like, not many people are looking at the ad, it might be priced too high, and we might need to adjust the price to attract more buyers. We can also group these variables into different categories, for example, the vehicle specifications, which contain gearbox, whether the car has a manual or automatic transmission. Power, the horsepower of the car. And the fuel type, whether the car runs on petrol, diesel, or another fuel type. The next grouping can be the condition of the car, which includes variables like not repaired damage variable, which indicates if the car has unrepaired damage. The kilometers variable, which is the total distance the car has been driven, which can give us an idea of how old and worn out the car might be. The seller details grouping, which tells whether the seller is a private individual or a commercial entity. Another grouping can be registration details, including the year of registration variable, which is the year the car was first registered. And the month of registration, which is the month the car was first registered. The next grouping can be car make and model, which includes the specific model type of the car, like i10, i20. And the brand of the car, for example BMW or Mercedes. Another grouping can be advertisement details, like the date when the ad was first created, the last time the ad was seen online. And the location of the seller, which might influence the price due to regional demand. By categorizing these variables, we can better understand how each one might impact the car's price. For example, vehicle specifications and the car's condition are directly related to its value and performance. The seller's details might influence how eager they are to sell. Registration details tell us about the car's age, and advertisement details can indicate how much interest the car is generating. Moving ahead, we will follow a similar process to the one used in the classification example. We'll clearly define our problem statement, which is to predict the price of a used car. This is a straightforward problem, so we won't need to break it down into subproblems. And next, we'll explore the data, perform any necessary preprocessing, and then build our regression model. This model will help us predict the price of pre-owned cars based on the variables we've discussed. In this case study, our goal is to predict a continuous numerical value, the price of pre-owned cars. Similar to the previous case study, we'll run several models to determine which one performs best, and we'll do all of this using Python. So, in this case also, with the dependent variable we aim to predict is the numerical price of the car. Our independent variables include a mix of numerical and categorical variables, such as the car's brand, model, year of registration, fuel type, and more. Moving ahead to the steps to approach the problem, our first step will be the data cleaning, which will include checking for missing values to identify any missing data in our dataset and decide how to handle it. And identify outliers, where we will look for data points that don't make sense, like a car with a price of $0 or a car with an unusually low power value. Outliers can distort the predictions and need to be addressed. The second step will be exploratory data analysis, which includes descriptive statistics to get an overview of the data distribution, central tendencies, and spread. And the visualization, where we use plots to understand the relationships between variables. This can help in identifying patterns and insights that are not immediately obvious. The third step will be feature engineering, where we handle categorical variables, in which we convert the categorical variables into numerical format using techniques like one-hot encoding. And scale numerical variables, where we normalize or standardize numerical variables to ensure they're on a comparable scale, which can improve model performance. The fourth step will be model building, where we train multiple models and will try different regression algorithms, like linear regression, decision trees or random forests, and evaluate their performance. And the hyperparameter tuning, where we optimize model parameters to improve performance. The fifth step would be the model evaluation, where we evaluate the performance by using metrics like mean squared error, root mean squared error, and R-squared to assess how well the model is performing. And we choose the best model based on the model that provides the best balance of accuracy and generalization. Next, we will move on to identifying and handling outliers is crucial in this case study. The outliers can twist the results and lead to inaccurate predictions. Here are two ways to handle outliers. First one is the formal mathematical methods, where we use techniques like the z-score or the interquartile range to identify outliers quantitatively. And the second one is the common sense approach. Sometimes common sense is enough to spot outliers. For instance, a car priced at $0 or a car with a power value of 1 HP is clearly an outlier and should be removed. The example of identifying outliers could be like, let's consider the car price. If most car prices are within the range of $1,000 to $50,000, but there are a few entries with a price of $100,000 or $0, those entries could be considered outliers. Similarly, if the car's power typically ranges between 50 HP to 500 HP, any entry with an exceptionally low or high value might be an outlier. This regression case study will help us understand how to predict continuous values and apply various regression models using Python. We'll follow a systematic approach, starting with data cleaning, exploratory data analysis, feature engineering, and model building, leading to a robust predictive model for the price of pre-owned cars. Next, we will look into the combining categories with low frequency, so when you have categories with very low frequency, it can be beneficial to combine them with other categories to create a more compact and manageable dataset. This helps in reducing noise and making the model more robust. For example, if you have a car brand that appears only a few times, you might combine it with another brand to streamline the analysis. Another important step will be of filtering data based on logical checks. It's crucial to filter the dataset to remove any illogical or incorrect entries. For instance, the price variable, if there are entries with a price of $0 or an unrealistically high price, these should be removed. In the year of registration variable, if the year of registration is beyond 2019 or far before the expected range, these entries should be removed. Similarly, if the power value of the car is unrealistic, it should be filtered out. We will explore two different techniques for predicting the price of pre-owned cars. First one is linear regression. This technique tries to fit a linear model to the data. It's simple, easy to understand, and interpret. It helps in analyzing variable importance straightforwardly. Another one is RandomForest. This is a nonlinear technique that often performs better than linear regression on complex datasets. However, it is more complex and harder to interpret. One of the most important aspects is to choose between linear regression and random forest, which depends on the model complexity, so linear regression is simpler and more interpretable, while random forest can handle more complexity but is harder to explain. If the random forest provides significantly better predictions, it might be worth using despite the complexity. And the application model, for example, if the model needs to be embedded in optimization processes, simplicity might be preferred. The next step involves regression diagnostics and assumption checks. After building a linear regression model, we need to perform regression diagnostics to check if the assumptions of linear regression hold true for our data. These assumptions include the linearity, where the relationship between the independent and dependent variables should be linear. The homoscedasticity, the residuals or the errors should have constant variance. The normality, the residuals should be normally distributed. And the independence, the observations should be independent of each other. Next, we will look into the performance metrics. The main performance metric for regression models is the error in prediction. The common metrics may include the mean absolute error, and the mean squared error, and root mean squared error, and the last one is R-squared. One of the most critical and important steps is improving the model, so if the initial model doesn't perform well, we will consider further data processing, which will include cleaning or transforming the data. And subsetting data, where we will build separate models for different subsets of data. For instance, creating separate models for low-priced and high-priced cars might yield better results. So, these insights come from your analysis after building the initial data science solution. You then evaluate whether it's good enough or needs further refinement to make the results acceptable for use. In the upcoming lecture, we'll dive into solving this entire problem using Python, exploring various choices, and providing a comprehensive solution to this problem. We hope that you have found this course informative and interesting. Please hit the like button and subscribe to our channel and stay tuned for upcoming courses. Your support means a lot and motivates us to create more educational resources for you. Stay tuned for the next lecture, where we'll continue our journey through our course Python for Data Science. Thank you for watching and see you again in our next lecture.